Hi everyone, so in this video I'll be covering Kirchhoff's current law. I'll discuss the theory behind it and provide some examples. So firstly we'll find where it originated from, Gustav Robert Kirchhoff, which was a German physicist. There he is there. He announced these laws in 1845 which calculated currents, voltages and resistances. One of these laws includes Kirchhoff's current law. So here's a theory. It states the algebraic sum of the currents entering and leaving a section of a network equals 0. Or you could say the sum of the currents entering a region of a network must equal the sum of the currents leaving the same region. An example is with water flowing through a river where it splits across with a ratio. Here it just enters and it leaves. It doesn't go anywhere else, which is like the current in a system. So it can be expressed in an equation form with the sum of the currents entering in equals the sum of the current exiting or leaving out of the region. It's a simple method to calculate the unknown current. Example 1, where we've got an electrical system with the current entering in, it splits off, goes back around and joins back together. So we want to find I1, I3, I4 and I5. So firstly we use Kirchhoff's current law at node A to calculate I1. So we've got the current entering in equals the current leaving. So I equals I1 plus I2. And we know what I and I2 is. So then we find I1 from there, which equals 2 amps. The next part, we want to find I3 and I4. This is very simple because I1 equals I3. So that the current entering node B equals the current leaving. It doesn't go anywhere else. Next, at I4 is the same because it just enters and leaves. Now we want to find the current I5, so we look at node D. We've got the current entering in, which is I3 and I4, equals the current leaving, which is I5. I3 plus I4 equals I5. It's very simple, equals 6 amps. And this is true because 6 amps entering equals 6 amps leaving the circuit. Now we've got another example where we've got the total current IS. That's what we want to find. So IS equals the total current that is distributed. So we look at Kirchhoff's current law, we've got the current entering equals the sum of the current leaving, which is I1, I2 and I3. So we add them up, very simple, IS equals 24 milliamps. Kirchhoff's current law is unquestionably one of the most important in this field because they can be applied to the most complex configurations in today's current electrical circuits.